Hi and welcome to this video. In this video, we will learn about basic data types in C and how to define your own variables of basic data types. Now, before we go to our main topic, I will firstly recommend you to solve these simple mathematical equations. So here we are given that x equals 2 and y equals 5. And we need to evaluate the corresponding value of z in the equations. So the first equation is z equals x plus y. So if you ever had solved this type of algebraic equation, then you will recognize x, y and z as variables. Now to solve this equation, you will replace the variables with their respective values. So you will write z equals 2 plus 5, and hence after doing the summation, we will get the value 7, which is then assigned to the variable z. Likewise, consider this equation. After replacing the values with the respective variables, we can easily solve the equation. In this case, the answer would be 5 minus 2, which is equal to 3. And now the variable z will hold the value 3. And consider this last equation. After putting the values of their respective variables, the z will get the value 19. So in loose terms, a variable stores a value, and then this variable can be used anywhere in the equation to represent the stored value. We use variables instead of pure numbers in equations because using the variables, we make the equation generic for all valid numbers. Now, a similar concept of variables applies in programming also. But in programming, we need to be more specific. That is, we need to explicitly tell the computer about data that will be stored in the variable. And this specific data is called a data type. So there are 4 basic data types in C. First is char, which is used to store a single character like alphabets in small caps and large caps, then numbers from 0 to 9 and some special symbols. The next is int, which stores whole numbers, that is numbers without decimal values. And the last two are float and double. They both are used to store numbers with decimal values. Double can store large decimal value numbers. Its range is 2 times that of float. For this video's purpose, we will only concentrate on the data type int. In future videos, we will learn about each and every data type. Now, as I said earlier, in programming, a variable must have a data type. Now, every data type has a size, that is a range of numbers allowed by that data type. For instance, on most of the operating systems, the int data type can store values in a 4-byte space, which hence allows up to 2 billion positive and negative values to be stored. In the next video, I will show you how the range is calculated for a given data type. So, in the int data type, the maximum number you can store is 2,147,483,647, and the minimum number you can store is minus 2,147,483,648. So roughly you can store numbers in order of 2 billion. Now let us see how variables are declared in C. So C is a static language. Thus, all variables should be declared before they are used. A variable declaration is a statement telling the compiler about its data type. So, the syntax for declaring a variable is like this. First you write the data type, then apply a space, and then write the variable name. For example, int space x and semicolon. So this statement will instruct the compiler to create a variable named x, which will store data of type int. Now we have declared our variable, but our variable is not assigned to any value. So let us see how to assign a value to a variable. So we use the equals operator, which is an assignment operator, to assign a value to the variable x. So here x will be assigned the value 15. So now whenever x is used, it will be replaced by the value 15. Now we can combine both declaration and assigning value to the variable in one step. It is called initialization. So we can write int x equals 15, and this will assign the value to the variable along with the declaration. And the last point is we can declare multiple variables on a single line if they are of the same data type. So in the example, we declare 3 variables, namely x, y, and z, which are of type int, and 2 of them are initialized to some values. We separate each variable by commas. So now it's time to apply what we have learned so far in the code. So open an empty file in Atom and save it with some file name. So we will begin by including the stdio.h file into our program. Then we will begin the main function. Now let us declare some variables. So here I have declared 3 variables all on different lines. If I had wished, then I could have declared all of them on the same line. But since it is our first time, I declared them separately on separate lines. Now the first variable's name is num1, second's name is num2, and the third's name is sum. Now I will be doing a separate video on how to name variables, but for now assume these variable names. Now let us assign values to our variables. So now num1 has value 5 and num2 has value 15. Thus now whenever num1 will be used, it will be replaced by the value 5, and similarly when num2 will be used, it will be replaced with the value 15. Now let us calculate the sum of these two variables and save it in the variable named sum. So this statement is just like the algebraic statement that we saw in the beginning of this video. So the sum variable will get the summation of values stored in num1 and num2. Hence it should be assigned with the value 5 plus 15, which is 20. We can check that by printing the value of our variables. So consider the following printf statement. So this printf statement is a little different. It have 2 arguments. One is the format control string, which is nothing but the string written within double quotes, and the other argument is the variable name. We cannot simply write the following printf statement. Because the num1 over here is a part of the string and it will be printed directly on the screen. It will not get replaced by its value. So for replacing the value stored in the variable, we write something known as a format specifier. So just like the escape sequences, which begins with the backslash, the format specifier begins with a percentage within the string. So whenever the compiler will encounter percentage in the string, it will combine its immediate next character to form a spatial meaning. Here we are dealing with only int values, hence I wrote %d. %d is simply a placeholder for the value of an int variable. The actual variable desired to be printed is written after the string by applying a comma. Hence here, num1 is the variable whose value will be printed in place of %d. So we can test it by seeing the output. So as you can see, it printed the value 5, which is stored in the variable num1. And in the second line, it just printed the string as it was written within the double quotes. Now let us come back to our code and let us print the values of other variables on screen. So I will just comment out this line of code so it does not shows up in the output. So these two printf statements are similar to the first printf statement. Here in the second printf statement, the value of num2 will be displayed, and in the third printf statement, the value of the variable sum will be displayed. So let us run to see the output. So it successfully printed the value of all the variables, and as you can check from the output, the variable sum is definitely assigned with the value 5 plus 15, which is 20. So now let us summarize everything we have learned in this video. So a data type, as the name suggests, is a type of data which can be stored in the computer. The four basic data types in C are char, int, float, and double. A variable is a memory location in the computer's memory which allows storing data in it. In C, all variables must be declared before they are used. %d is a format specifier which is written within the string. It acts like a placeholder to be replaced by an actual value stored in a variable. The variable is written outside the string in the printf statement and is separated by a comma. So, for example, in this printf statement, the %d is a placeholder for the value stored in the variable num1. There are other format specifiers also for other data types. We will see all those as we work with other data types in future. So that's all for this video. Thank you for watching it. Meet you in future video.